Welcome to another unusual GCSE maths questions.
So today's question is from the 2020 Edexcel series, so there's only one paper that year because of COVID. So this is paper 2, question 22?
22, yeah.
Okay.
And this is a question about equations of circles, and we'll put it on the screen now for you to look at.
Cool.
Okay, that's long enough to do, isn't it? Right, so...
Go on, do you want to... So we've got the tangent through the point, the coordinates minus 20, 0 and 0, 10, and we want to find the equation of the circle. So this tangent to the circle.
Right, so the first thing about this question is you've got to draw it.
I was going to say.
You've got to do a sketch.
Yeah,
so
100% do a sketch.
I see Grace has gone for the draw the axes before the circle. I'm more of a draw the circle and then put the axes in later kind of person.
I like that.
Let's see how this goes.
Yes, yeah. I don't think that's a very egg shape, but it's not bad.
So that's 10 and that's 20. You know what? Do we care? I don't think we care. Do we care?
That's not what it says. No, you're saying that's 10 and that's 20. No, you're thinking the tangent. The tangent's got to go to 20. I mean, what are you talking about?
That distance.
Yeah, it's 10 and that's 10.
And that distance.
It's 10 still.
Oh, I see, yeah.
Yeah. It's, in fact, that's not even... This isn't even 10. This is...
It's actually a very good sketch, isn't it?
I'm going to go with my sketch. Right, okay.
Okay, so shall we go?
Oh, see, I thought our pens were different colours, but they're really not, are they? Okay, so now let's mark the coordinates in. Yeah, so, I don't know how you cope with that. Right, okay, right, so, it's so funny how different we are. Right, okay.
One of these days, isn't it?
It really is. So should we start? I think we should start by finding the equation of this line.
Right, so if we could find the equation of the line, that would be helpful, yeah.
Yeah, I think so. So should we start by finding the gradient of the line then?
Notice that we've decided to find the equation of the line without really knowing whether that's going to be helpful.
Yeah.
We just looked at it and said, and this is what you got to do sometimes, just look at it and go, what can we possibly do here?
I think we've got a line from the equation.
Yeah, also, should we put that in? And because equations of tangents to circles, they're usually to do with radiuses meeting tangents at 90 degrees. So that's circle theorem that you would have learned when you did circle theorems. Comes back in these questions. It's always a feature of these questions.
Okay, so should we start with that? So
Grace is going to work out the equation of the line.
So equation of the line is y equals mx plus c. So let's start with the gradient. So the gradient is the change in y over change in x. So you can see the should I do both parts? The change in y here, if you can see this triangle, is 10. If you want to, you could do 10 take away 0 for completeness, because it's this y coordinate take away that one. And then here, the change in x is 0. Yeah, it's probably best we do it.
Because there is a GCSE question on one of the papers where they give you 2 points that don't have zeros in.
Yeah.
So remember this formula for finding the gradient of a line.
Yeah. So it's the y coordinate take away the y and the x take away the x. And it probably is best because here you can see that the difference is going to be 20. However, it's 0 take away minus 20, which is a plus. So that gives us 10 over 20, which is a half. Okay, so the gradient is a half. So if we plug this back in, we've got y equals a half x plus c, and now we want to find the y-intercept. So do you want to do that, or should I keep going?
Yeah, the y-intercept is 10, because they've labelled it.
No, didn't even think yet.
Look for the obvious things.
Yeah, I was going to plug it back in and everything. Right, okay.
Right, so useful or not useful, we've now got the equation of this line. Y equals a half x plus 10. Right, so let's clear some space again.
And then let's come back to this concept, okay? So that the radius meets the tangent at a right angle, okay? And then we have to use our knowledge of straight line graphs as well. So if you have two lines which are perpendicular, the gradient of the perpendicular line is going to be the negative reciprocal.
Okay, so if the gradient of this one then is a half, the gradient of this, you're going to flip the half over to get 2 over 1, which is 2, and then change the sign. So the gradient here is minus 2. Don't forget, by the way, that if you ever have to show that two lines are perpendicular, you can, the mark scheme does allow you to say negative reciprocal, but it's better to say that they multiply together to make minus 1. That looks a little bit more like you're a proper maths student. Okay, so if the gradient here is minus 2, then the line is just y equals minus 2x, isn't it? Because it goes through the origin. It doesn't have so it doesn't have an intercept. Clearly it does, but it's 0, yeah? So it's so it's just that. Okay, do you want to do the next bit?
No, go on, I'll
carry on.
You keep going.
Okay, well there's probably different ways to do this, but the most straightforward way is going to be to find this point of intersection and then just find the distance between here and there to get the radius. That's probably the easiest way to do it. So if I want to find the place where two lines cross, that's simultaneous equations. These are the equations.
Because they're the two lines that
They're the two lines, yeah. I'm just going to do a straightforward substitution. So if y equals that, but y equals that, then that equals that, because they both equal y. So if I go half x plus 10 equals minus 2x. Again, different ways you can do this. I'm going to times everything by 2 to get rid of the fractions. I'm going to times everything by 2. And then let's bring the minus 4x over, so add 4x to both sides. So we've got 5x plus 20. And at some point, you're just going to spot the answer, aren't you? It depends how much you want to write, really. But we're going to have x equals minus 4. So,
go on. So now you've got, go on. So if you've got x equals minus 4, to get the y coordinate, you just plug it back into there. So y equals minus 2 multiplied by minus 4, which equals 8.
Right, so let's put that on the diagram.
And go for it. So what was it? Minus 4, 8.
Minus 4, 8.
Lovely.
So now, shame we haven't got a different colour.
So we've got black.
Yeah, right, so now.
Oh, or blue.
Or blue, yeah. So now what we've got is a right angled triangle that the radius of the circle is the hypotenuse of, and we can see that that is a distance of 4, and that is a difference of 8. So how are we going to find that? We're going to do Pythagoras. Do you want to do it? Yeah, go on, you do it down there.
Okay, so Pythagoras' theorem is a squared plus b squared equals c squared, where c is the hypotenuse. So we're going to do 4 squared plus 8 squared equals c squared. 4 squared is 16, that is a 4, I promise, plus 64. 16 plus 64 is, wow, that took me too long in my head, 80.
And if we stop there, because actually, we don't want c, do we? We actually want c squared, don't we?
Oh, of course we do.
For the equation of a circle.
Yeah.
So if the equation of the circle is x squared plus y squared equals r squared, where this is r, r squared, which is 80, x squared plus y squared equals 80, and that's it.
And we're done. So once again, we started by just sketching the diagram and then going with the flow. We didn't really know that this is what we had to do, but
yeah, this is the thing. Like, and I think this is the point of these videos. Really, is that the unusual questions, if they're unusual, so when you see them, you're not going to immediately go, I can see exactly what to do. So what you need to have is a bunch of general ideas that you can apply to a question that you don't know how to do. And you know that if you just follow these ideas, at some point you'll see what to do.
it is bound to lead you somewhere.
And so in this case, it's things like draw a diagram. And the idea of this idea that whenever you've got tangents to circles, it's almost always going to be to do with radiuses and tangents meeting at 90 degrees. It's always part of it.
Yeah. And then from there, like you said, when you have two lines which are perpendicular to each other, that the gradients, when you multiply them together, equal negative.
And then there's the idea that if you're trying to find where two lines cross, it's simultaneous equations. You need to have just all these little facts in your head, and then you can just apply them one at a time, and eventually the answer comes out.
Yeah.
That's how you do it.
Cool.
Okay, any other unusual questions, let us know and we'll do those next.
Cool.
Cool.
Bye.
Bye.